Hi everyone, I am Umeshwar, a PhD student from Professor Wu-Ching Chou's laboratory, Taiwan. My current research focuses on oxide film epitaxy. Today, I will show you how to grow oxide film using molecular beam epitaxy system. Molecular beam epitaxy system uses ultra-high vacuum conditions. In order to maintain good vacuum environment, we should avoid contamination. We do that by wearing necessary clothing. Before starting the experiment, it is mandatory to wear the overcoat, gloves, cap, shoes and mask. Only we can maintain a good environment. Today I will show you how to grow the gallium oxide thin film onto the sapphire substrate, and here is the sapphire substrate sticked onto the moly using the indium metal. The first step is loading this substrate into the load lock chamber by breaking the vacuum inside it. This is the MBE system we use to do the epitaxy. Here is the main chamber with the vacuum in the exponential orders of -10 or -11 torr. This is the load lock chamber where we need to place the substrate initially, and the pressure inside is in the order of 10⁻⁻8 torr. We need to break the vacuum inside the load lock chamber and bring it to the atmospheric pressure to open the door and place our substrate. To do that, we should stop the pumping system and vent the nitrogen gas inside. The vacuum inside the load lock chamber is created by the small turbo pump. The pump is currently working now. We need to isolate the pump from the load lock chamber before turning it off, and we do that by closing the gate valve. The turbo pump is working with a rotational frequency of 1500 Hz. We can turn it off now. After reaching the pump rotation frequency to 0 Hz, first we have to open the door lock of the introduction chamber. Now we can vent the nitrogen gas into chamber. Here is the controller for venting the nitrogen gas into the load lock chamber. We have to set the nitrogen vent to a value of 5 psi. We have to slowly vent the nitrogen gas into the LL chamber. We can see the pressure in the gauge meter. This is the opening valve for the nitrogen gas. We should slowly open it by checking the pressure. Once it reaches to atmospheric pressure, the door will open automatically, and we use these tongs to place the substrate into LL chamber. Lock the door, close the valve, stop venting the nitrogen gas. To create the vacuum again, open the load lock gate valve. open the small turbo pump once the pressure reaches 10 power minus 1. When the load lock chamber's pressure reaches less than 5 times 10 power minus 7, we can load the substrate into the growth chamber. Increase the height of the blocks. Slowly move the transport rod. Decrease the block's height to place the moly on transport rod. Slowly open the introduction valve by checking the pressure inside the chamber. Gently move the transport rod from load lock chamber to the growth chamber. Increase the height of the stage such that the C-shaped ring catches the moly. Lock the stage. Use the stage spinner to rotate the stage for checking the proper alignment. After confirming the proper alignment, gently take back the transport rod from growth chamber. Slowly close the introduction valve. This is the power control box. We can see the working temperatures of all the effusion cells from this box. We use the robo control software from the computer to raise the temperature of the cells. Before raising the temperature of desired effusion cells, we must set the temperature of all the cells and stage to 100 degrees with a raising ramp rate of 3 degrees per minute. This is the setting temperature and this is the ramp rate. Before starting the experiment, we need to turn on the read power supply on the power controller box. Also, we need to turn on the plasma power supply. We increase the read power after 30 minutes from opening. Now we can turn on the read power. We should increase the voltage to 12 kV and current to 1.5 ampere. As per the growth schedule, increase the stage temperature with a ramp rate of 10. Before opening the oxygen plasma, I will explain few important steps we need to follow to take care of the equipment in the growth chamber. Here are two setting modes for the growth chamber gate valve, which are interlock and bypass. Setting to interlock will close the gate valve automatically when there is high pressure inside the chamber. The bypass mode is used whenever we use the radio frequency plasma in the growth process to bypass the closing of gate valve. Along with this, we also have to close the flux gauge because the highly reactive ionized species inside the chamber from plasma exerts more pressure which can damage the equipment. So we turn off this one. Then we have to open the oxygen valves connected to the gas lines. After opening the oxygen valves, we need to use the mass flow controller to control the flow of the gas into the chamber. First, we need to open the lock and then use this rotating knob to control the flow of the gas. We can see the value of increment in the robo control software. Here is the radio frequency plasma generating equipment, which is connected to one of the cell port of growth chamber. Once we turn on the flow into chamber, we can check the plasma ignition. A purple color light will be seen in this viewport, which indicates the plasma ignition. If it does not start yet, then we press the ignition starter button and then check again. However, if it still fails, then we close the final nitrogen valve for few seconds and then open again. During this step, we have to be very cautious about the chamber pressure, and by closing and opening the valve, any gradient in the gas flow will be eliminated and a continuous gas flow will be maintained along the gas inlet throughout the chamber. We should warm plasma gun before 30 minutes. Turn on the RF generator control. Then set it to 50 watts. Now we have to reduce the reflected power using the variable capacitor knob. We need to reduce the reflected power to a minimum for efficient generation of active species in the plasma. Repeat the same steps for every 50 watts until 300 watts. It's time to open the oxygen plasma. First, set the growth gate valve from interlock to bypass mode. Then turn off the flux filament. And open the oxygen valves. Now we use the mass flow controller to control the gas flow. Open MFC and use the tuning knob to control the flow. Check the flow from the computer. Check whether the ignition has started or not. It did not start yet. Push the igniter button. Still, it did not start it. Now we close the oxygen valve for few seconds and open again. The plasma has ignited. Now tune the variable capacitor to reduce the reflected power to a minimum value. Now open the oxygen setter. Once the cells and stage reach the setting temperature, run the recipe. Open the main shutter. Turn on the read controller and open the read screen shutter to analyze the in situ real-time surface reconstructions. After the completion of the growth, close the main shutter. And open the closed cell shutters if any. Close the RF generator. Close the oxygen valves. Close the MFC and reduce the oxygen flow to 0 SECM. Reduce the power to 0 watts. Now the chamber pressure is good enough to open the flux filament. So we will open the flux filament. Set the growth gate valve from bypass to interlock and reduce the read power supply. Turn off the RF generator power supply. Turn off the read power supply. Once the stage reaches 150 degrees, we can load out the sample from the growth chamber. Slowly open the introduction valve. Move the transport rod gently into the introduction chamber. Unlock the stage. Decrease the stage height such that the moly is landed on the transport rod. Gently move back the transport rod. Close the introduction valve. Increase the blocks to catch the moly. Take back the transport rod completely. Close the load lock gate valve. Turn off the turbo pump. Open the load lock chamber door. Set the vent to 5 psi. Open the nitrogen valve to break the vacuum. Open the door and take back the sample. Close and lock the door. Close the nitrogen valve. Stop venting the gas. Turn on load lock gate valve. When the load lock chamber pressure reaches -1, turn on the turbo pump.